All right. When we look for the vertical asymptote, we look at the denominator. So we need to figure out where the denominator is equal to 0. And to find that, just set it equal to 0. When we solve for x, what do we get? So that means we have a vertical asymptote at x equal to 2. How do we find horizontal asymptote? Yeah, we look at the degrees, or the highest exponents. So the degree in the numerator is 2 and the degree in the denominator is 1. What does that tell us about the horizontal asymptote? There is none, right? So the degree in the numerator is higher than the degree in the denominator. The degree in the numerator is higher than the degree in the denominator, so there is none. Exactly. How do we find slant asymptotes? We have to use division, right? But what do we need to check for before we can do that? So first, we have to make sure that there's no horizontal asymptote, which there isn't, and the degree in the numerator is 1 more than the degree in the denominator. So the degree in the numerator is exactly 1 more than the degree in the denominator, so we do have a slant asymptote for this one. And remember, we saw 2 different ways we can figure this one out. We can use synthetic division, or we can use long division. We're allowed to use synthetic division for this one because we have x minus a number. If it was something like x squared plus x plus something, then we would have to use long division. So let's use synthetic division for this one. How do we set it up? We have our little box. What goes on the outside? Yeah. So we solve for x, we get x equal to 2, and that's what goes out here. What goes on the inside? 1. What else? -1. And -2. Remember, we get these numbers from the coefficients of the numerator. And we do not skip terms. First thing we do, we bring it down and then multiply. And we add, multiply. And now we bring back our variables. We started with x squared, so this one is going to start with x. And we get x minus 1. Sorry, x plus 1. So our slant asymptote is y equal to x plus 1. Any questions on that one? Zeros. How do we find zeros? Yeah. To find the zeros, we just set the denominator equal to 0. And we already did that when we were looking for the vertical asymptote. And we see that we have x equal to 2. But we don't want to put it down as a 0 yet, just in case it's a hole. How do we know if it's a hole? How do we find holes? Yeah, we factor out the numerator and the denominator. So what do we get when we factor this? We get x minus 2 and x plus 1, and then we have x minus 2 in the denominator. Does anything cancel out? Yeah, so since we canceled out x minus 2, we have a hole at x minus 2. So we have a hole at x equals to 2, and we had a 0 at x equal to 2. The hole overpowers it, so we actually do not have any zeros. But we have one hole. We actually have to write our hole as a point. So the x value is 2. What is the y value? To find the y value, we take the x value and plug it into whatever's left. So if we plug 2 into whatever's left, what's left? What do we get? 3. So we have a hole at 2, 3. I don't think I mentioned that last class. All right, so after we've determined that we have a hole, we take whatever that hole is and plug it into what's left of the fraction, and that'll give the y value. If we were to graph this function, you'll see that we actually do have a hole at 2, 3. Okay, so we factored the denominator and then set it equal to 0 to find the vertical asymptote. What about horizontal? Yep. The degree in the denominator is higher than the degree in the numerator, so y equal to 0 is our horizontal asymptote. Do we have a slant asymptote? We do not have a slant asymptote. Why is that? Right. Because we have a horizontal asymptote, we cannot have a slant asymptote. You can't have both. All right. Zeros. Remember, we find the zeros the same way we find the vertical asymptote. So for now, we have x equal to 3 and x equal to -1. But we can't put it down as a 0 yet until we make sure it's not a hole. All right, the numerator is already factored, and we factored the denominator earlier. So do we have a hole? Yeah. The x plus 1 cancels out, so we have a hole with an x value of -1. What would the y value be for that? So to find the y value, we have to plug it into whatever's left. Yeah, the denominator is -4. So our hole is going to be at -1, -1/4. And we have a 0 at x equal to 3. We can write our zeros as a point. That'll be 3, 0. So 0 is basically the same thing as x-intercept. That's why we can write it as a point like that. Any questions? So we know that 180 degrees divided by pi is equal to 1 radian, right? So we're trying to figure out how many radians we get from 0 degrees. For 0 degrees, we have 0 radian. And for 30 degrees, you have pi over 6 radian and pi over 4, pi over 3, pi over 2. Do you guys remember this? But you have seen it before. Two pi over 3 and 3 pi over 4. And 5 pi over 6. Pi. 3 pi over 2 and 2 pi. All right, so basically all we did to get from here to here, we had 30 degrees, and we multiply that by pi over 180 to figure out what the radian is. So if we multiply 30 by pi over 180, what is 30 divided by 180? You're allowed to use a calculator. What's 3 divided by 18? Can we simplify that? Yeah. And, huh? Yeah, we would have 6 in the denominator. So 30 becomes pi over 6. 45 times pi over 180. Yep. So you get 45 times pi over 180, and that's pi over 4. So to get from degrees to radian, you have to multiply by pi over 3. Sorry, by pi over 180. To get from radians to degrees, you have to multiply by 180 over pi. All right? What are the 6 basic trig functions? No. Cosine is one of them. Tangent. Tangent is another. Sine. Do you remember the others? Not for this one yet. Right now, we're just naming them. Remember cosecant, secant, and cotangent. So we have cosine, sine, tangent, cosecant, secant, and cotangent. All right. When we're trying to figure out what the angle is for each one, we have to use a triangle. And we always use a right triangle. To find the angle for using cosine, we always look at adjacent over hypotenuse. So for cosine, we have adjacent over hypotenuse. And if we use the variables that we have here, which one is adjacent? Yeah. the x is adjacent to the angle, and the hypotenuse is r. So these are all different ways we can represent cosine. What about sine? Do you remember what that one was? Opposite over hypotenuse. Should have left more space. And sine, you said, was opposite over hypotenuse. And which one is opposite at the angle? Yeah, so this one would be y over r. Tangent. What is tangent? What letters represent that? Almost. Do you remember what secant was? Secant is the reciprocal of cosine. So what would the reciprocal of cosine be? Both. And it is also equal to 1 over cosine, because the secant is the reciprocal of cosine. Reciprocal means we flip it, right? Cosecant is the reciprocal of which trig function? Yeah, it's the reciprocal of sine. So this one will be hypotenuse over opposite. All right, and the last one is cotangent. That is the reciprocal of which function? Yeah, it's the reciprocal of tangent. So how would we describe it? Yep. And adjacent over opposite is x over y. There is another way to represent tangent. Do you know? If we use these two to represent tangent, do you remember what it was? One over tangent is cotangent. So we can use sine and cosine to represent tangent. Do you remember which one is on top? Which one's on bottom? Opposite goes with sine, adjacent goes with cosine. So tangent can also be represented as sine over cosine. And if cotangent is the reciprocal of that, what would that be? What? Yeah, cosine over sine. This should all be reviewed to you guys. Is it? Or is this new? Okay. Well, are we good so far? Alright, so all we've done so far is just list the 6 different trig functions and how to identify them or represent them. Do you remember how to use the unit circle? Okay. We'll add that to the list then. All right, who remembers Pythagorean's theorem? Okay, we have a squared plus b squared equals c squared. All right, and we can only use it with right triangles, right? And this is usually A, this is B, and this is C, right? In the triangle I had on the previous page, we had this as x, this as y, and this as r. So what would Pythagorean's theorem be with this one? Okay. So on the unit circle, we can draw a right triangle, and that shows us how to read the angles. When we read the angles, x is usually which trig function? Do you remember? X corresponds to which trig function? X corresponds to which trig function? Yes, x corresponds to cosine, and y corresponds to sine. So we can rewrite our Pythagorean's theorem using sine and cosine. Do you remember what the radius of the unit circle is? If you don't, it's equal to 1. So we went from the Algebra 2 version of Pythagorean's theorem to a trig version of Pythagorean's theorem. And from here, we can derive different forms of Pythagorean's theorem. To do that, we have to divide each term first by cosine. That gives you one other identity. And to find the second one, we have to divide everything by sine. So if we divide everything by cosine, this becomes 1. What is sine squared divided by cosine? What's sine divided by cosine? Tangent. And what is 1 over cosine? Almost. It's secant. Alright, so we took the original Pythagorean's theorem and derived it to find another version of it. Now to find the third version of it, we have to divide everything by sine. So we have cosine squared divided by sine squared plus 1 equal to 1 over sine squared. What's cosine over sine? Yep. And what is 1 over sine? Yep. All right, so these are the 3 ways to represent Pythagorean's theorem using trig functions. Evaluating trig functions. If I ask you to find what sine of pi over 4 is, do you know how to do that? Okay, I'm going to assume no. So if we're asked to find sine of theta, where theta is any angle, on a unit circle, our answer is going to be given by the y coordinate. And if we're asked to find cosine of any angle, it's always going to be given by the x coordinate. So over here we see x and y, right? Now if I ask you to find what sine of pi over 4, what would that be? You go to pi over 4, sine is which value? So what would this equal? Yeah. Did you guys do this? What if I asked you to find cosine 2 pi over 3? So 2 pi over 3 is over here. Cosine is the x value, so yeah, negative 1/2. What about sine 11 pi over 3? Is 11 pi over 3 on the unit circle? No, it's not. So what do you think you're supposed to do? So let's think about it. When we go around the whole circle, that's 2 pi, right? So making one complete revolution around the circle is 2 pi. 2 pi is the same thing as 6 pi over 3, right? I'd like some feedback. Yes, no, that's all I'm asking. When we go around the unit circle one time, that's 2 pi, right? And if we want to represent it in terms of threes, 2 pi is the same thing as 6 pi over 3, right? So 11 pi over 3 is bigger than 6 pi over 3. That means we went around the circle once to get to 6 pi over 3, and then we kept going to get to 11 pi over 3. So to figure out what that reference angle is, you take 11 pi over 3 and subtract it by 6 pi over 3. We get 5 pi over 3. It's 5 pi over 3 on the unit circle. It's over here, right? So what do you think this answer would be? You guys didn't do this? To find the sine, cosine, or tangent of an angle, usually that angle has to be either from 0 to 360 degrees or from 0 to 2 pi. If the angle they're asking you to find is greater than 360 or 2 pi, we have to find what the reference angle is. And to find the reference angle, we subtract it by 2 pi. Or 360, depending on if they give you degrees or radian. So 11 pi over 3 is greater than 2 pi. So we have to figure out what the reference angle would be by subtracting 2 pi. And when we subtract the 2 pi, we see that the reference angle is 5 pi over 3. So we started at 0. We went all the way around 2 pi, and we kept going, and we finally stopped at 5 pi over 3. That's what 11 pi over 3 is. We just went around a full circle, and we went again and stopped over here. All right, so if I asked you to find cosine of (17 pi over 6). 17 pi over 6 is more than 2 pi, right? So to figure out what the reference angle is going to be, we have to take 17 pi over 6 and subtract it by 2 pi, but we want the denominator to be 6, so what goes in the numerator? Yeah. And what do we get? So this is the same thing as asking you to find cosine of 5 pi over 6. And we can actually do this one by looking on the unit circle, because 5 pi over 6 is on there. So what is cosine of 5 pi over 6? Yeah. Okay, let's try it in degrees. So what if I ask you to find cosine of 560 degrees? What can we simplify cosine of 560 degrees to? Yeah, that's exactly what you do. So we take 560 and we subtract 360, and we get what? Yeah, let me pick a better number. So we take 570 and subtract 360, we get 210, right? So we're really trying to find what cosine of 210 is. What is cosine of 210? Where is 210 on the unit circle? At 7 pi over 6. And what is cosine at 7 pi over 6? Right. Right. Let's try one with tangent. So if I want you to find tangent of 225 degrees, how would you do that? So this one is less than 360, so we don't have to subtract anything. We can just go to 225, which is 5 pi over 4. What is tangent at 5 pi over 4? I'll help. So the best way to approach this one is to break tangent in terms of sine and cosine. What is tangent in terms of sine and cosine? So we want to find what sine of 225 divided by cosine of 225 is. What is sine of 225? And what is cosine of 225? So if we simplify this, what do we get? Is this making sense? Okay. All right, let's try one of the other ones. What if I ask you to find cosecant 5 pi over 3. What would that be? So cosecant is which trig function? If we write it in terms of sine and cosine, what is it? Cosecant is sine, and it's going to be 1 over sine, right? So what is sine at 5 pi over 3? How do we get rid of this fraction in the denominator? We flip it and make it a reciprocal.